In this video, we are going to talk about what is functional programming. Then we will go into Lambda functions, we will see its syntax, and then we will learn about how we can use those Lambda functions inside higher order functions. We will see what is higher order functions and how we can use them along with Lambda functions. There are three main higher order functions. These are map, filter, and reduce. We will learn about all of these functions in this video. Let's first conceptually understand what is functional programming. Functional programming is a different style of programming, just like procedural programming or object-oriented programming. If you have background in object-oriented programming, then you might remember that objects are the main way to modularize our code. But in functional programming, we construct different computations based on functions. Let's discuss some of the main features of functional programming. First, functions are treated as first-class citizens in that programming language. What does this mean? This means we can pass functions around just like any other primitive data type. Just like we can pass integer data type into any function as a parameter, we can also pass a function into function as a parameter. We can also return a function as the return value. The second attribute is that it provides referential transparency. This means it does not change or modify any variables inside the function. If we have a variable and if we have to change that variable, then we simply create a brand new variable instead of modifying the earlier one. The third attribute is that functions have no side effects. These kind of functions are also called pure functions. This is also related to referential transparency. This means if we pass the same variable to the same function, then it will produce the same result all the time. This also means that the variable has not been changed. If the variable was changed, then the function call would have produced a different result depending on the value of the variable. But it conflicts with the second attribute of the functional programming. So now we understand what is functional programming. We will clearly see the first attribute, which is we can pass functions around when we discuss about higher order functions, and we will also see referential transparency that will be visible when we want to convert one list into another list. We won't need to modify any of the variable. We will simply transform them using higher order functions and Lambda functions. Now this brings us to our next point. What is Lambda functions? Lambda functions are derived from the mathematical concept of lambda calculus. This provides a very short and easy syntax to write anonymous functions. These functions are mostly used only once in our code, and that's why they do not need any name and they are called anonymous functions. Under the hood, it results in the same bytecode as any other normal functions. These are also known as lambda expressions or simply lambda. Let's take a look at an example of this. Here I have got a very simple definition of a Python function. It has a name and it also takes a parameter number. This returns a Boolean result depending on whether the number is even or odd. If we want to write an equivalent lambda functions for this, then we can write it like this. So in the syntax, you can see lambda functions are written using the keyword lambda. This is followed by the parameters that we want to pass inside the function. Lambda functions usually tend to be very short. They usually have only one line of code or two lines of code. In this case, whatever value we want to return is written after this colon symbol. and I have assigned this function object to this isEven variable, but it's not required. From the syntax, you can see that Lambda functions do not require the def keyword. It doesn't even need those parentheses to provide the arguments. Also, we can omit the return statement and simply write whatever we want to return. So this way, this syntax tends to be very elegant and simple. Let's understand more about these Lambda functions in code. Let's take a simple example. Let's say I have a function square which takes a number and it simply returns the square of this number. Now, if I call this function with a value 2, then it will simply return the value 4. If we want to define an equivalent Lambda function, then we can use the Lambda keyword. And after that, we can specify whatever arguments we want to pass into this function. In this case, we only want to pass single argument, so I write x. After this colon symbol, we can specify the return value for this lambda. In this case, I want to return the square of this number. This is a very simple syntax for defining a lambda function. We simply pass the parameter and then we only specify the return value. We don't need to write the def keyword or return statement, nor do we need to write the name for a function. But in this case, to test it out, we need to provide some kind of name. So let's write lambda square. Now, if I call this function with the same value, then it will provide 4. So this way we can define an equivalent lambda for a specific function. We will make use of these lambda functions when we explore the higher order functions like map, filter, and reduce. Let's first understand about higher order functions. Higher order functions are the functions that take other functions as their parameters. In most functional programming languages, there are 3 main higher order functions. These are map, filter, and reduce. Python supports all 3 operations in 3 different functions. Map function is used to convert a collection into another type of collection. Let's suppose we have numbers list and let's say we want to add 10 to all the numbers. In that case, the size of the sequence is not going to change, but only the values are going to change. So in this case, we can use map function. Filter function can be used to select only specific elements based on some predicate function. Here, predicate function simply means a function that can return either true or false. Let's suppose we have student marks in a list and we want to get marks of only those students who have got more than 50. So in that case, we can provide a predicate function which will check whether a student has got more than 50 and it will only filter out those student marks which are more than 50. Reduce function can be used to aggregate elements. Taking our last example a little bit forward, if we want to get the sum of all the student marks in a class, then we can use reduce function. Let's take a code snippet of all these functions. Here I have got this numbers list with elements 1 to 4. If I want to transform this list into a Boolean list which checks whether a number is odd or even, then I can use a map function. Here you can see that our map function takes a lambda expression. This is the expression that is applied to all the elements of our input list. In this case, it only checks whether a number is even or odd. For all even numbers, it simply returns true, and for odd numbers, it returns a false. Let's say we want to filter out only the even numbers. In that case, we can use the filter function. So here the lambda expression is the same, and wherever we were getting the value true, those elements are included in the output list. Reduce function is little bit different in that it takes an accumulator and the element from the numbers list. It goes through and performs the specified operation on all the elements of this list. In this case, I am specifying to sum all the elements. So it returns a single value of 10. Let's get back to our notebook and explore these functions. Let's take a look at higher order functions. First, we are going to take a look at map function. Let's say we have users' names in a list: Anil, Alex, and Jennifer. Let's imagine that I want to get the length of each of these names. For that, I can use the map function. So I can write map. As a first argument, it takes a lambda expression that will be applied to all the elements of this list. So here I'm writing a lambda expression, lambda x, and for each element I want to find the length of that element. So here my lambda expression would look like this. As an input, I want to pass this names list. Let's assign it to a variable length of names. Let's check the length of names. It returns a map object. So when we use this map function, the return type is a map object. If we check the data type of this length of names variable, then it returns a map. We can convert it to any concrete data type like list or tuple by wrapping it inside that function. For example, to convert it to a list, I can simply wrap it inside a list function, and now it returns the length of each of those elements. Now let's check a very simple example of filter function. Filter function can be used to filter out elements. Let's suppose we want to filter only those users whose name starts with character A. In that case, I can check the first character of each of these strings. So I can write a filter, and in the lambda function, I can check if name's first character is equal to A. If that's the case, then those elements will be included in the output list. Let's wrap it inside a list function. And now it returns only those users whose name starts with character A. Now let's take a little bit larger example. Here I'm going to copy the users list, which contains the user information. It contains information in the form of a dictionary. It has name, age, profession, industry, and salary. In this very simple example, I have got only 5 users, but in real life there can be many users. Let's execute this cell, and now we have this users list available in our Jupyter notebook. Now let's suppose that I want to get only the salaries for each of these users. Then we can map all of this user data into their salary list. For that, we can use the map function. So I can write map. It takes a lambda function, and in each iteration, it's going to take a user information. So it will have this dictionary as its input in each iteration. I want to get only the user's salary, so as a return statement I can write user salary. My input is going to be the users list, and let's also wrap it inside a list function. I'm assigning it to salaries variable, and now we can see that we have got the salary of each of these users. If I want to filter out only the users who work in the information technology industry, then I can make use of a filter function. If you take a look at this users dictionary, it has got this industry field which specifies in which industry this user works. So I have this user Alex who is into information technology, and I also have Steve who works in IT industry. So let's see how we can filter out only those two elements. So I can write a filter, and in each iteration it's going to be users. Here I can check if the user's industry is information technology. Let's wrap it inside a list function. And here I get an error. This is quite common. You will always come across this kind of errors. In this case, it's a simple typo. It should be users, not user. So I correct it, and if I execute, I get only Alex and Steve. Now with this functional programming style, we can also chain different operations to one another. For example, if I wanted to get the salaries of only the IT users, then I can first filter out the elements who works in the IT industry, and then I can map those users to their salaries. So first, let's filter out the users who work in the information technology industry. In this case, I can make use of this code. So it will filter out IT users, and then I can map these users to their salaries. So my input in this case can be this filtered users. And I also need to provide a Lambda expression. So my Lambda expression is going to be user, and I want user's salary. Let's also wrap it inside a list function so that we can get only the list of salaries. If I execute, I get the salary of Alex and Steve. Now let's look at reduce function. Reduce function is not available in the core Python library. It is into a separate module itself. So we first need to import reduce function from functools. So let's first check the documentation of this reduce function. If I write help reduce, it gives me this simple document on this reduce function. It takes a function. In this case, we can provide a lambda, and as a second argument, it takes a sequence that we want to work on. We will discuss about this initial value later on. Here it also gives a very simple example of reduce function. If we pass a list containing 5 elements, and if we pass a lambda function that tries to add all the elements, then it will perform this action. It will first sum 1 and 2, then it will add 3, 4 and 5. Let's try this example in our code. Let's create numbers list with elements 1 to 5. Let's check the reduce function. It takes a lambda with 2 arguments. In this case, I'm naming my first argument as sum. This will be the accumulator, so here I'm writing it as sum. As a function implementation, we are simply going to add 2 numbers. Let's execute, and we get back 15, which is the sum of all these numbers. If our numbers list was empty, let's say there are no elements, and now if I execute this cell, it throws a type error. Reduce of empty sequence with no initial value. This is where we can use this initial value argument. If there are no elements, then Python gets confused about which value to return. If I pass initial value of 0, then Python is happy. Now let's write 3 elements, and now if I check, then it correctly returns the sum of all 3 elements. If we want to multiply all the elements of this numbers list, then we simply have to change this Lambda implementation. Everything else will remain the same. Let's try that. In this case, I'm going to name my accumulator as product, and I'm going to multiply each number. Also, I have to make sure that I'm passing initial value of 1, because 0 multiplied by any number will always return in 0. If I execute, it returns 6. But if I add one more element, then it returns the multiplication of all 4 numbers. Let's get back to our users list. If we recall, we have this users list with all the user information. Let's suppose that we want to get the sum of salaries for all the users who are older than 30 years of age. So in this case, we have this John who is getting 75,000 as salary, and we also have this user who is getting 43,000. Let's say we want to get the sum of those 2 users' salaries. Then we can use the combination of filter, map, and reduce. First, we can filter out the elements. First, we can filter out the users who are older than 30 years of age. So in this case, I'm checking user's age, and if it's more than 30, then I'm adding it to my variable. Now we can use this filter users variable and map their salaries. So let's create a new variable, salaries, which maps these users into their salaries. Now we have got the salaries of only those 2 users who are older than 30 years of age. Finally, I can use the reduce function to get the sum of their salaries like this. And for clarity, I'm also passing initial value of 0. Let's execute, and we get the sum of salaries for those 2 users, 75,000 and 43,000. Now this brings us to another point. We have seen 3 different methods to transform our list. First, we have for loops. Then we have seen list comprehension. And finally, we have seen the map function. So which one should you be using? My recommendation is to write list comprehension for very simple and easy transformations, because list comprehensions are lazily evaluated and they are very fast and efficient. If you have to write complicated code, then probably you should go for map function. So in this video, we covered functional programming in Python. We looked at what are Lambda functions, and we also saw few higher order functions like map, filter, and reduce. In the next video, we are going to talk about file handling in Python.